Hi, welcome back to the UBC Biophysics and Medical Physics Student Society YouTube channel. Today we'll be hearing from Dr. Anthony Chan, the program head of the Biomedical Engineering Technology program at BCIT. This is a 2-year diploma program where you learn how to become a biomedical engineering technologist.
What do people learn in this program?
Okay, the program at BCIT is quite unique in terms of not just in BC, across Canada as well as internationally. We are a 2-year diploma program, unlike university 4 or 5 years to finish. Students finish 2 years and they get a technology diploma. They become biomedical engineering technologists, and there's a high demand of people working in the field right now. So our program, the minimum entrance requirements, you can go to our website and look at it, is high school graduation with some science subject and language skill works for sure, right? In terms of student population, about 50%, sometimes more or less, from high school, straight from high school. But most of our students, for example, this year we have almost, I think, over 50% of students who has a degree before they come into our program.
What are the typical types of degrees people already have?
Science, mostly science degree like biology, chemistry, kinesiology, but we also have some student that has an arts degree. But you may not believe it, like, doesn't matter whether they have a degree to come in, whether they have science background or whatever. When they finish, right, whatever, how successful they are in getting a job or advancing in the field, really depends on their own, whether they are interested in the field or not.
I see. Yeah. So the graduates who have a degree versus not don't have a leg up.
Well, the first semester maybe, because they have some advantage in math and whatever, and they are a little bit more mature. But as time's moved on, right, they will be in equal playing field.
I see.
So a typical medical device lab, or how the student learn about medical devices. Give you an example. This is an electrosurgical unit. During surgery, for example, people think about, well, if you want to cut open a patient or remove some tissue, right, you'll be using a sharp scalpel, right? But nowadays, most of the procedure, they are using what we call electrosurgical unit. So what it does is it generates a high voltage, high frequency current. Depending on the waveform and magnitude of the current, they can do different things, right? For example, it can be like a knife. You want to try?
Sure.
I can, well, it doesn't cut you open, right?
Yeah.
It looks like a knife, right?
Yeah.
That doesn't cut you open. But if I plug it in and then started to, if I plug it in, I energize the unit, which of course I don't want to, right? Right? It will produce a very high frequency, high voltage current, and it can slide open your tissue like a piece of butter, right? Sliding over a piece of butter, right? So this is a very common device to be used during surgery nowadays. The beauty of this is it will do the cutting, but it will also coagulate, stop bleeding on small tissue, so the surgeon will get a clean feel. So a device like that, when students learn about this device, in the lectures we will talk about this principle that I just told you, show them the waveform, what waveform can do the cutting, what waveform type will do the coagulation, etc. And then talk about how to generate this current using electronic components and the hardware. And then we'll also talk about the construction, right? Identify some of the key components of these type of medical device. So students learn all about that, and then they come to the labs, right? The first lab, like most of the medical device, we want them to experience or learn how devices are being used, right? So they will in this particular lab, we'll give them some tissues, right? Some beef, pork, or whatever, and they can do the cutting and coagulation, right? Experiment and getting some feeling about the coagulation, cut waveform, etc. So after that, we will ask them to look at the waveform on the oscilloscope using, this is high voltage, so they need to use some device to step down the voltage. And then display the waveform on the oscilloscope, and then they will be checking the waveform, looking at different type of waveform, trying to find out whether or not the power setting agree with what is being output, right? Basically, they are doing a simple performance inspection on the unit using very primitive, basic laboratory type of equipment. So after that, we will give them this type of specialized device, which are used in the field, because using the primitive method to do one checking inspection will take hours, right? Not to mention about the initial setup. So in the hospital, for example, they cannot afford to spend that much time, right, in checking one piece of equipment. So at VGX, they may have maybe 20, 30 of this, right, in the hospital, or even more. So these devices are designed specifically to test electrosurgical unit. So in nutshell, I just plug this device into this device, turn on this device, and then this device will look at all the parameters and say whether this is according to the specification, whether it pass or fail, right? So the student will be able to understand the basic principle, right, of the construction, as well as they know what they can use in the field to test this technology. And also in the lecture and also in the lab, they will be experimenting some safety features of this unit, because these are very dangerous devices, right? You can hurt patients as well as hurt the people standing by. So they learn about the safety precaution, and there are some safety feature built into this device. So they learn the whole scope of that. So they learn all about, in the first year, they are learning the fundamentals, right? For example, chemistry, more advanced level, physics, math, right? Electronics, which is the big part. Most of the student that came in doesn't have any electronic background, so there are a number of electronic courses, and then also computer courses, software courses, and then so the first year is more we call fundamental year, and then when they move on to the second year, then they get more into the medical device standards, regulations, right, and then the fundamentals of medical devices. Computer networking, and then eventually, right, they learn about the practice, for example, technology management, how they work in the hospital, how this hospital are organized, and then at the very end of their second year, they all will be working in a company for 5 weeks. We call it practicum term. So they will be, say, go to a hospital, VGH or whatever, they work side by side with the biomedical engineering technologists there. But one thing that I've forgotten to mention is we are very emphasized on laboratory and the hand skills, because that's the most part of the work, right, as a technologist. So we have in first year, end of first year, we have a 5 weeks practical workshops, skill workshops. So what students learn is one workshop is on mechanical skills, for example, right? The first lecture will be recognize what are the simple tools, like even screwdrivers, right? Nice. How to select a proper screwdriver for proper type of work, right? And then goes on to other mechanical skills, like taking apart equipment, how to repair strip screws, etc. Right, yeah. And then lead on to some simple power tools. Another type of workshop is 3D printing, for example, right? how to do printing, scanning, etc. And then the other one which I want to mention is the sort of we call it biomedical engineering skills, which is a lump of lots of different skills. For example, recognizing different materials, what adhesive can be used for the materials, right? For example, incubator, their hood has a crack, right? Rather than throw away and then buy another, spend another $1,000 for just hood, they can actually repair them, right? So those are the mechanical skills that the student learn from the program.
Cool. Sounds very practical, very useful.
Yeah, it's practical. We try to differentiate from the university program that we are very practical, and also we are very focused. UBC Biomedical Engineering program, I know because I actually was quite involved at the very beginning, right? They are more broad-based in terms of biomedical engineering training, but our program is focused in medical device technology, which is a very focused area of the biomedical engineering.
I see.
Yeah. Now, our program is what you can call a fixed program. There's no elective, there's no options, right? You come in, every student are taking the same course, right? So every term there are a number of fixed courses that students need to take and pass before they move on to the next level. But for some students, for example, if they have a physics degree, then quite often they can apply for a transfer credit, right? So they don't need to take maybe some math and some physics course. But all the courses they have to finish and pass before they can graduate. So there's no pick and choose of what they want to do. However, in recent years, there are more and more students saying that, I really cannot handle the full load. Okay. Now, imagine 2-year program, you come in, right, with almost no prior knowledge in the area. After you finish, you will be able to function as an entry-level biomedical engineering technologist. So there are a lot of material, content that students need to learn and practice. The program, I wouldn't say is difficult, but it's intense. Okay. Some students, they came in, they have to work. Well, because living in Vancouver is expensive, right? So some may say at the very beginning or after the first term, I cannot handle the load. Can I take less courses? We are sort of flexible in certain way for that, but then these students will take more than 2 years to finish, right? Maybe 3 or even 4 years to finish the program. So in terms of flexibility, we can do. And then some students say, I want to go to, say, online, right? To complete some of the courses. We can do the evaluation, right? And then if it's sort of matching the learning outcome, then we'll allow the student to do that. So in terms of flexibility, that's what we are trying to do.
Do people often end up where their practicum was, or do they do different things?
Not necessary. Practicum, we have probably maybe 60 or 70 recognized practicum sites that we have agreement with, right? Including hospital, including some clinic, including some medical device company. They do development and manufacturing of medical device in town, right? So we have, and also across Canada, we have many practicum sites. So some student may be interested to go to work in a hospital later on. They may choose a site, a hospital site. Right? Some may want to try out, for example, work for a private company like GE Philips, right? And we have practicum arrangement with GE and Philips. So they can pick and choose where they go. And then after 5 weeks, they finish. If the company have opening, usually these students will have advantage, but not often, right? Sometimes they may have to apply to some other places. But employment for the last 3 years was very good.
Okay, that's good to hear.
Yeah.
Very
So
practical.
most of our grad can get a job within a few months after graduation. Okay, starting with salary, right? Can tell you the job market is quite good. I would say almost red hot at the moment, right? Last year the hospital was saying that we are not graduating enough graduate for them to hire. So, but that's that may be a little bit over exaggerated. Now, 50% about half of the graduating class will end up working in the hospital, and also public sector, right? Public sector maybe including UBC, working in some labs or whatever, or cancer agency or whatever. So the public sector job right now, I think the pay is about 75,000 a year, right? So that's the starting pay in the public sector. If they go to the private sector, right, for example, joining GE, Philips, the starting pay might be a little bit lower. I don't know, right? It really depends on how badly they want to hire the person, right? But the private sector usually have other perks, right? For example, give you a company car. Nowadays, if you work for it's a field service rep, you don't need to go to any office or whatever. Just work from home. When you need, you just go to the site, right? So there's different lifestyle and also different things that people consider. So that's about the job and the pay. What else? What were you asking?
Just like growth potential within the career.
Yeah. Now, growth potential, if you work in the public sector, right? Usually, right, in general, every year you get an increment because of your experience, year of service, right? But also there are other areas that you can become, for example, become a supervisor rather than a working level temp, right? Or you can get some special skills, for example, networking. You become a guru in computer networking, cybersecurity, right? You can move to a specialty category. Now, our program first graduating class was 1969.
Okay.
So many of our grads are really at very high level in government, in private company, etc. So they may be the director, they may become president even in some organization. So advancement is there. It really depends on the individual. Of course, now it's not that you sit there and then you get promoted immediately. Well, most of the time, right, you get increment, but at a certain point you become the top level, right? But then a lot of our grads want to learn more, right? They may go back to school. They may take on some special skills, right? And our program try to facilitate that, right? Although we are a 2-year program, we have identified some pathway for our grads if they want to advance, right? For example, in management area or in the engineering field, they can take some courses or join some other program to become a professional engineer. Right?
Okay, very cool.
Yeah.
And the other thing about the program is that it's very small, so you get lots of hands-on time with stuff.
Well, right? With university, you may walk into a lecture hall with 200 students, right? That you don't know tomorrow you'll be with it. But our program, most of the program at BCIT is, especially in this health sciences, right? Allied health is small, right? Maybe 20, 30 students, right? And then you'll be always together with the same cohort. So you know your friends very well. So it's small, as well as our faculty, our primary job is teaching and education. So some faculty do a little bit of research on the side, but our primary job is teaching. So we have open office hours. Students can walk in, right, during the hours and ask questions or whatever.
That's very nice. It sounds very supportive.
Yeah. We don't have TA though.
Well, it sounds like you don't need it.
Yeah, it's all done by the instructors.
No, that's awesome.
Yeah.
And obviously, you guys seem very passionate about it. Are a lot of the instructors previous grads of the program, or
some are? I didn't graduate from this program, but we have faculty who graduated from this program, and after they work for many years, and they decide to come back as an instructor.
Very cool.
Yeah. Okay, so within the Biomedical Engineering Technology program, there's a project course. The idea of project course is to get the student to apply what they have learned into building a project. So the students start usually is in around this time of the year, the second year student. So they will be given some information about what is the project cost and what is the nature of the project cost. And they will start to think about what they want to do. So sometimes we get projects from external, and then we'll try to align students to the external clients, and then they will initialize the project from scratch, in general usually from scratch, and then they will get some idea. And they project usually in recent years are 2 to 3 students form a team. So they will think about what to do this term, and then the actual project course start in January, which they will need to do the preliminary design, right? Come up with the specification of the device, and then actually starting to build the project, and then testing the project. And hopefully sometimes if there's client, they will work with the client, and then at the end, right, the project will be tested out by the clients, and sometimes they give the project to the client to use if it is appropriate. So that's the process. During the process, the student is not just building a gadget. They are following the design criteria that is in line with the regulatory approval guidelines, like the FDA, whatever. So they have to follow rules, proper documentation, going through hazard analysis, etc. We try to encourage students to use the project to enter into engineering design competition. In recent years, some students, almost every year, 1 or 2 teams enter into some engineering design competition, and oftentimes they won some prizes, right? Competing with university students, right? Engineering or college students. So what I'm trying to show you is a project, this current project this year. So this project is for a person that has disability, like a paraplegic, need to sit on the wheelchair, have very limited use of their hand, right? So what this project does is, when the person wants to drink juice or water, right, usually it's positioned near the hands. So when the person wants to drink, we'll try to move the head and then put it in the mouth, right? And then press a button somewhere, or try to use some other activator like a sip and puff controller, whatever, to activate a pump, so the water will come out from the bottle, and then it will squirt into the mouth of the client. But oftentimes, right, you do that and it's maybe spread, like it will be going all over the face and whatever. So it's not too convenient, it's not too good. So this student came up with the idea, instead of you push a button, this will come out, the water will come out. They designed this device here. Here, this is a reservoir to hold just one mouthful, about one mouthful of fluid. When the client wants to drink, right, activate the device, there's a pump inside to pump the water or the fluid, and then fill this reservoir. So there's a flow sensor and whatever, make sure that this won't be overfilled. So after that, the client will put his mouth and then bite on this particular nozzle, and there's a sensor inside. When it's bite on it, it will open the valve, and then the fluid will go inside the mouth of the person. So make sure that this is already inside the mouth of the patient, of the person, sorry. So this device is fully functional, although it's still a prototype. It still needs some refinement before it can be deployed. But the client said, well, it works. It's worked quite nicely. So this team of students put this into a engineering design competition, the Simon Cox student design competition, in April, I think in April or May, and they won one of the free prizes of the competition. Okay. So this is the student idea, student product, and they make it manufactured from almost from scratch.